Welcome to our last lesson of Unit 5. So we're wrapping up coordinate geometry here. And we're just tying all together those pieces of transformations meets coordinate geometry. So we're talking about that last rigid motion of translation here. So we have AB shown. We know that the AB image is going to be translated 5 units left and 3 units up. So remember, anytime you do that, it's like saying 5 units left is subtracting 5 for the x, which would change this to -7. And b prime is going to be a 2. And we're going 3 units up. So if we go 3 units up, we're adding 3 to the y's. So it's like having -5 and +7. So that being said, we could have just strictly done it this way. Remember, you can always count and just double check that that's true. So if I'm thinking 5 units left, I'm counting 5 units to the left, which is in fact at that -7. And we're going up 3. And there's our A prime. Same thing for B prime. We're going 5 left and 3 up. And when we do this, we should notice something very special here, but I'm going to let you try to figure out what's so special about it. So pause this video, calculate the length of AB and A prime B prime using the distance formula, and then calculate the slope of AB and A prime B prime, and we'll wrap some ideas up. Welcome back. From B, when you use the distance formula, we should have gotten 15 for both AB and A prime B prime. So we plug in the distance formulas and simplify. Same thing with the slope. Now the slope you could have just counted up and over, rise over run, delta y over delta x. I just plugged into the formulas just to double check. So both of them simplified to 4/3. So right now we know that those two lines have the same length, which checks out because rigid motions preserve lengths. And remember, translation had a special property. Translations keep lines parallel to one another. So AB should be parallel to A prime B prime, which we know because they have the same slope. Now, scooting right along here, like all rigid motions, translations preserve shape and size of an object. Remember, we will never write that on the regions because that would never get us full credit. It's always got to be length and angle measure. Size and shape, unfortunately, is only 1 point, so we don't want to get confused with that. They also map line segments to other line segments that are parallel to the origin, so we're combining all 3. So we're looking at the diagram where we have kite ABCD has undergone 2 transformations. Which sequence of transformations maps ABCD onto A prime, B prime, C prime, D prime, then onto the double primes. So let's first look from ABCD to A prime, D prime, C prime. So let's look. If we're going from here to here, these directions, notice the order of the points A, B, C, D haven't changed at all. They're still in that same order. It's just like sliding this transformation onto one another, but I just gave it away. Anything that's like a slide, that's a translation. So if it's not starting with a translation, it is not for us. So 1 and 4 are gone. And think, if it's turning, we want to think about rotations, but we want to double check the order of the points because remember how we used to get trapped in the beginning. So if I look at my order of my points, A, B, C, D, but A, B, C, D, notice they're in different directions. If they're in different directions of one another, that means that a reflection happened. Don't fall for that trap because of the turn. Remember, we just recently learned about a new line that we can reflect over. We can pretend that there's like a y equals x situation going on here where I would fold along that line. Or it doesn't even have to be y equals x. It looks like it might be, but even if it was just some line in between there, okay? So we can fold along that line, but if the order of the points changes, it's got to be a reflection. Now, two figures, if you have a sequence of rigid motions, we know they're congruent if they map onto one another. I have two parallelograms here, and there's two different sequences you can show. Really, there's not just two, okay? So there's many, many, many different ways you can go about doing this. So if we started with one of the more popular ones, now I want to give two different sequences. Now, one thing that we want to be sure of, though, is that we're mapping these onto each other. So I'm going to say maybe we'll start with a reflection over, let's say, the y-axis. So I'm going to reflect A, B, C, D onto. So that means if I reflect, I'm looking at C prime. D prime would be 2 away. A prime would be 8 away. And B prime would be here. Oops. So now it's like a good start. We'd still need to map these onto one another, but we can finish this off by having a translation. Now notice how specific I'm being. I wrote over the exact line I wanted to, and I'm going to say exactly how much I want to translate. So I'm going to say 2 units, or 1 unit to the right, rather. And let's see how many we have to go up. 7 units up. To get full credit, you do have to be that specific. Now, you might have thought of a different way, and it could be easier, and that's fine. There's so many different ways we can go about these transformations. It's fine. So let me just erase that for a second and do a different one. And I'm going to do one that is similar to what we've dealt with already, but I'm still going to keep that same theme. But I'm going to reflect over, let's say, I'm going to say the line y equals 1. So I'm going to switch it up. Before we went over the y-axis, now we're going to go y equals 1. Remember, that's a horizontal line that we've talked about recently. And I'm going to reflect here now. So I'm counting up 2 for this B prime. C prime's up 2 and up 2. D prime is up 5. And A prime is up 5. Oops. Well, I put my A prime in the wrong spots. And then, only thing left for us to do is translate over. $10 units. Right. Now I can get away with this in this one because there was no given sequence. Like, it didn't tell me that A, B, C, D had to map onto E, H, G, F. Like, it doesn't say which order. So from the sequence 1 and sequence 2, I've done them opposite, but it's okay because it never said how to map them. Usually you'll be given like A, B, C, D onto this order of the points. Okay, and those aren't the only 2 ways of doing it, right? You can do it a plethora of different ways. As long as it maps onto one another, you're okay. Okay. Now it's different for exercise 4. We're going to do, it can be mapped onto, so EFG, the triangle, is mapped onto MNP by a sequence of transformations. If the first one's 90 degrees about the origin, then what must be the second? So go ahead and rotate 90 degrees. Remember, you would take XY and change it to negative YX. And after you plot that one, see if you can determine what that transformation remaining is. Before you actually pause that video, realize I just saw something that we should be careful of. Clockwise rotation of 90, right? This first one, that's regular 90. We want to rotate it the negative 90. So that's really y negative x. It's the same as a rotation of 270. So that's really the point you're going to rotate it around. So be careful. So if you rotated 270 degrees or clockwise 90 degrees, these would have been my new coordinates for E prime, F prime, and G prime. So that rotation would have gone into the first quadrant. The only transformation needed to make E map on to M and F map on to N and P map on to G is a reflection. But remember, we want to find that exact line that falls on the line in between. So I can count 6 total space between like F and N. So I want to cut that in half because remember, a line of reflection is like a perpendicular bisector. It's bisected by cutting that distance in half. And if I drew the line through like this, it'd be perpendicular. So we want to be specific though. So it's got to be a reflection over, and that line is y equals -2. Okay, last one for us here. We want a sequence of rigid motions that could be used to map triangle ABC onto WXY. So remember, ABC, triangle WXY. I always stack my points so I know that A is going to W, B is going to X, and C is going to Y. So I'll give you a chance to look through and decide which one's the best one here. Okay, if I was to do a clockwise rotation of 90 degrees, that's going to change this point A from 2,8 to 8 -2. So that would be A prime at the moment. B prime, B here, and C prime would be about here. So if I rotate that, the problem is if I just do a single reflection across the y-axis, that's not going to map these onto each other. It definitely can't be one. A counterclockwise of 90, however, that's going to plot our points. B's at 2, 4. This would be B prime, A prime, and C prime. And this is a reflection over the line y equals 1. That's still not going to work because we're still not mapped up enough to be a reflection. So another one gone. So now let's see the reflection of the line y equals -x. So remember that line comes in here. And then a translation of 2 units to the right and 3 units up. So if I reflected, these points are going to switch and negate. So if I have the point 2, 8, it's going -8, -2.